Hey everybody. Um, I'm going to talk about um, Flip and the Atmel DFU bootloaders, and because I've been asked, well, how would these things be updated in the field? Um, well, when I did the Cobra 2000 thing, I deliberately picked an AVR that had a USB port, so that it could be field upgraded. A lot of the previous ones, you pretty much had to have a JTAG programmer to update them. Prototypes, yeah, but this one's more of a real thing than a prototype. So basically, we have our board, and um, we have, which is kind of a duh, I suppose. We have a over here a USB port. And I actually need to move this footprint a little bit closer to the edge. But we have a footprint here. Uh, so we would have our micro USB plug into it and uh, pretty much it. The schematic or how this thing is interfaced with the radio is fairly simple. The microcontroller has a D plus D minus. This is its USB right here. And hence the D plus and the D minus. This is I'm going to play around with this, but this is a not required. It's currently not used. And then of course when we look up here, we have our connector and our D plus D minus some little resistors. These are actually protectors. Um, we are in this case. I do have the capability of drawing power from USB, which is what the two diodes are and the resistor and all that kind of. This is just to detect power. My thought process here was is if we're getting power from USB, we don't want to run the full program for one. And the second thing is that we want to go straight to bootloader. We just don't want to run the program if we have a cable plugged in. So that's kind of the thought. But I have to try uh, to see how that works. Presumably, all I would have to do is just jump to address 0 and it should execute the bootloader. Um, you know, so if I look at this pin and say, okay, well, there's power here, which means I got the USB plugged in, so therefore I should just go into bootloader. But if I jump to address 0, I think that should work. To just start right to the beginning. And this, of course, makes sure that we're 5 volts on our USB. We've got two diodes back to back, so we're going to drop that down to a more manageable voltage. Because even though the device can run on 5 volts, not everything on that 3-volt line can run on 5 volts, such as um, this crystal oscillator will be death to it. So yeah, so it's just simple USB thing. Um, nothing too fancy, um, and you know it's very simple. So that we have the document. It's AVR 1916, and this talks about how this essentially works. I mean, and this is quite literally, as you see in the schematic, quite literally it. Um, so we're interested in this section right here, which is the part configuration. Um, and obviously you need to flash the bootloader with one of the tools, STK600, the AVR ISP, JTAG ICE, whatever. You see, I've got the Atmel ICE, um, and we have to look at if we have to set fuses, and we have to set lock bits if necessary before we put before we start using the bootloader. So if we look at the fuse bits for this particular part, um, they're talking about this one. The default is actually here, okay? But it needs to be changed to bootloader reset. And this is so the bootloader can reset the device. Um, so that's pretty much all you need to change. You can obviously set whatever else you need to set up, but I've already changed this. You have lock bits, and we can set these lock bits, so that you know nobody can read out the um, the program in the microcontroller. But I'm not setting any lock bits because this is a prototype, and if I set lock bits, I'm going to lock myself out. So I don't want to do that. So lock bits are done. Um, so of course, then we have the boot process. And how this works is like anything else. It turns on. It looks for uh, a condition, if you will, like a pin. Is a pin grounded, so on and so forth. Is the part blank? If so, just run the bootloader. If there's an application, just go ahead and run it, pretty much. So, um, we start up. Is there a pin condition? No. Is the part blank? No. Run the program. Um, and that's essentially it. So we're going to um, program this device now with the bootloader. So we're going to pick, and here's another thing for illustration. Go to Device Manager, and over here where Atmel is this the only thing that we've got visible here is the Atmel ICE. Another device will show up in the list that is a USB device when uh, you know when it's programmed. So we're going to pick a corresponding bootloader for this particular part. So it's a 128 Xmega 128A3U. So we need to find it, and there it is right there. So we're going to open that. We're going to program this, and we're going to, of course, verify we're good. Everything's happy, hunky-dory. We'll close that. It hasn't shown up yet because I haven't plugged in the USB cable. So when I plug in the USB cable, there's our chime, and there's our Atmel USB device, which is our AT Xmega 128A3U. So everybody's happy. Now we go to flip. So um, we're going to load the hex file that we want. In this case, this is the application that we're going to flash. We're going to select our target, ATX Mega 128A3U. You've got all these parts that you can flash with this. We're going to connect to it over USB, and it's going to do some things, such as it's going to look and see we got bootloader version 1.0.4, which is what was in that file name, and it's happy. So what we're going to do is we don't want to erase its memory. We want to blank check it. So blank check pass. It's blank. We're going to then program it, and it's just done that quick. Well, that doesn't seem very reasonable now, does it? Um, let's make sure that I've actually got a hex file loaded. Okay, there's our hex file. Program device. Okay, it did it. It's just small programs, really fast. Um, so we can verify. Verify down here verifies pass. It's good. Now I have two choices. I can start it from here. I can pull the USB cable out and reset it, whatever. I'll just hit this. Of course, the device disconnected, and actually on the display now, I can see the program is running. So it's happy. And that pretty much concludes the usefulness of Flip at this point. We don't need it anymore. Um, so anyways, while I'm at it, I had to fix these mounting holes. I ain't done it yet. I did fix up this ground situation up here. Um, I also need to fix this USB connector. It's not quite. Um, this needs to be closer to the edge. It's an oops. I wasn't thinking about it. I stuck it on the board. That needs to overhang slightly because of the connector So it's a little crooked on the board. Um, crooked in this direction. It's sort of like lifted up a little bit. It's not exactly flush because of the lip at the bottom of it where the connector plugs in. So here's our little power supply deal where we're vampiring some power from USB to power it. And that's basically it. Um, nothing too fancy. So just gotta move this, fix these things up, and then I probably be ready to get another one of these made. Um, but I am gonna um, muck around with it some more because I have found some uh, some little bugaboos, obviously. Like this ground up here was wrong, and some of these mounting holes are a little off, and this grounding is a little bit too close to this pad. Like I said, that USB connector, um, just minor, relatively minor stuff. Um, Other than that, it's been working fine. So that's basically it. Um, I hope this was interesting for those, especially who've been asking about well how this works and how well it works. I won't say that it's perfect. Um, I will say that it even has its clumsy moments, but it really, for the most part, it does work. Um, it, there's lots of other ways to do it. Like I could write my own application to do it and try to utilize their protocol, which they do have documented for those who are interested. Um, I think this is it right here. Yep, there's their DFU protocol all here um, in 15 pages. So, um, that's up to you guys. And I mean, the code's available too. They pretty much give you everything. So, um, does it's just not very difficult. So, anyways, hope you guys enjoyed that. Hope it was interesting. Um, if not, sorry. But the next time I should have this board back in the radio, um, and you know, uh, should have something to show. So, I had to fix it because I actually let some of the blue smoke out in an oops. Um, Long story short on that, a probe slip over here on this connector and fed something into something that shouldn't have been fed into, and then bye bye. Killed the two-wire interface on the microcontroller, blew up the synthesizer, and killed the display. All in all, a very bad death. So, oops. Anyway, guys, that'll be all for now. I'll catch you guys later.